Thank you folks for joining here. This talk was supposed to be presented by one of my teammate as well, but he couldn't make it because of some family emergency. But we miss you, Rong. So yeah, today I'll be talking few things about how we address some of the reliability and velocity challenges that we saw uh, while we were building a model serving platform with Racer. A little bit about me. I joined Zoox last year in October. I work on a model serving platform. Internally, we call it ZServe. So if I use the word ZServe, I'm just talking about the model serving platform that we are building. I focus mostly on the traditional ML models. They are still relevant in many use cases, although people I think have forgotten. And LLMs and also multi-modal LLM models for different use cases that we serve at Zoox. About Zoox, if you don't know about it, it's an autonomous ride-hailing company. If you look at the picture, it's a vehicle that was built from scratch around the rider experience. If you are interested in taking a ride in it, it's live in Las Vegas, and it's arriving soon in SF. So if you want to keep track of it, go to zoox.com. It will have all the information you need. I can hype up Zoox a lot, but I think no matter what words I say will not be sufficient enough to justify how great the experience is when you take the ride. So highly recommend that if you can, do take a ride. So before we dive deeper, let's set some context. As I talk about ZServe's model serving platform, so being an autonomous vehicle company, there is a lot of inference that goes on the vehicle. But about a year ago or a little more than that, we realized that there are still a lot of use cases that can benefit from a offline model serving platform. So these are the use cases like once the robot has already acted, there's a lot of robot data that comes along, and there are many use cases like triage, and you need like ML models to classify what triage events those are. We also run a lot of simulation in the offline scenarios, and to test the new models that are coming up, and the new model capabilities that we want to test. So all of those things can happen on offline serving platform. So we started building offline ML inference services around 1 year ago on top of Ray-Serve, and we use Amazon EKS as a compute. We started with dozens of models, but now since we have been evolving since last year, and we serve like more than 100 models today in production. At a very high level, ZServe it leverages all the advantages that you get from Ray-Serve. So it's agnostic of data formats, ML frameworks. It allows easily to use the proprietary data types. And since since we are in the AV space, we have a lot of multimodal data. And I don't know if you have attended some of the talks that talks about images and videos, but those are like, if you are pre-processing some of those kind of data types, you need pretty heavy CPU intensive workloads as well. So they are pretty CPU intensive workloads. So you need heterogeneous compute for inference and for pre-processing. So that definitely helps since we are using Ray. Ray has a very strong integration with you get very strong Kubernetes support if you use Kubernetes, and we do. This is like a typical journey of a query. If once the model is hosted on ZServe, we give an endpoint over users, and this is basically a typical journey of a query where like a user can send a request. We encode the request into a Z request format. Basically, it abstracts away all the compression that we do on the request and all those things from our users. Then we decode it at our server end. We do the inference and we send the response back. As we were growing, we started discussing what are some North Star goal for a model serving platform internally. So we started talking to our users and internally MLP engineers. And one of the line that was basically discussed stood out for us, and that was like, hey, we want to make deploying and serving models as fast as pushing code. And as safe as and stable in a production system. So like that's basically what we want to achieve with our ML serving platform. Just a quick thing, there is no timer here, so if I can get it. Yeah, so talking about those, so we basically looked at two things as North Star as a goal. One is velocity and another one is reliability. So these are the two things we care about the most while we are building anything on model serving platform. So why velocity? So what we realize is like ML is like almost 90% experimentation and 10% production. Our users innovate faster if they can iterate quickly, and ML teams tend to stay ahead if they are iterating quickly. So that's basically the reason why we chose velocity as one of the North Star goal. Reliability as a platform, I think reliability is a main pillar because that builds a trust with your users. So your users, once they use your platform, they should feel like they want to come back, they want to use your platform more and more. And if your system is not reliable, no matter how good the features are, most users tend to then just go away and build something else or look somewhere else. Yeah, and once the model is in production and the reliability is not good, the failures can be costly. We have a lot of workflows that are running on our platform, and wrong decisions or delayed decisions can result into many things that we don't want our users to go through. So yeah, let's talk about if these are the two the goals of your platform, then we started looking into what are the pain points. And I don't know if how many of you have used RayServe, but one of the very common way of deploying a RayServe application or a service is you have a Kubernetes Helm templates. You declare what your Ray cluster resources are, and then you have a serve config where you can declare, hey, this is my serve application. And you can set up your backend code, and it will allow you to onboard models. So that's what the process we had when we started. But the pain points are now, if you want to introduce a new model, then you need to make a change there. Somebody needs to review it, and we are a very small team. The ZServe team is literally 3 people, so somebody needs to come and review that Helm template, and the users of our platform don't have deployment permissions in our system. So somebody will need to review it. They'll need to go and deploy or change. So if that definitely hits your iteration velocity very quickly, if you are in a mode where you are exploring something new, then you are just basically bottlenecked by somebody available to review, give you a stamp, and then allow you to merge. Then we'll go and sync on Argo CD, and your model will get deployed. And that is even worse when you want to just remove your model and free up some resources, because removing the model might also means that you go through the same old process again. From the reliability pain points, so we quickly understood that the use cases that we are supporting, they are sort of very diverse enough. Some of them are very latency sensitive. They are very small models, but some of them are very big models. And when the request comes, it basically has a good bulky batch request, and they expect high throughput. Some of the models are just getting traffic during nighttime, and they are bursty. So what we quickly realize is it's very hard for us to set the user expectations. If you are onboarding a new model onto a same let's say Ray cluster, because when a high throughput request comes, it can have some impact on how the network bandwidth is available. Or bursty QPS means if your auto scaling config is set in a way, it will spin up the new resources, but it might start impacting some other use cases that are on the Ray cluster. And then from a reliability point of view, also want to make sure when models are getting onboarded, we want to make sure that they compatible with our platform. So we had CI tests for those, but CI tests can be slow sometimes, and especially if you want to remediate certain issue and you are stuck in getting a model out or model onboarded, then they tend to have a time to remediations were going up sometimes. And also if you have such varied use cases, if you want to simulate a prod behavior in, let's say, staging environment for scale testing, now that is a different challenge. How do I simulate a bursty QPS or a latency sensitive traffic and high throughput traffic, and setting everything up is a little hard. So again, we went to the whiteboard, started understanding our users, and how we are developing for our users, how users are using our platform, and the 4 points quickly stood out for us. So we need to give our users a space where they can test quickly. And when I say test is like, hey, I have this model, I want to send a test request to see what it responds with, if it's failing, if it's compatible with your platform, and all those stuff. Uh, we also realized quickly that, like, we need some level of isolation, but now we need to decide how do we isolate different models on our platform so that it makes the most sense for us. Reliability checks should be faster, and once the reliability checks are done, we should feel comfortable the model is ready for promoting to production. And if we can, like, we want self-serve model deployments with configs that our platform understands and users understand. If we achieve these, we'll be able to, like, hit the pain points that we just discussed. So how do we achieve this? So the step one was like isolation of compute or like Ray cluster. So we came up with like, based on your use case, we understand now, we feel comfortable enough to guide you in, like, what kind of resources you might need, what kind of like, GPU, CPU ratios you might need. And we'll create a isolated Ray cluster for you, which is your area, and whatever you do on it will not impact other users of our platform. This also allowed us to simulate like, any prod behavior in staging environments very quickly. So that allowed us to, if you want to scale test very quickly, how the platform is going to do with like new models, anything, it's very easy for us. But we also want to make sure that our users are not struggling with all these new isolation techniques that we are bringing in. So we started building tooling that allows us to like, create templates for Ray clusters and sub applications, and we abstract away all those details of from our client users, and they really don't care if we are isolating the resources. They just know that, hey, I want to send a serving request to this particular model, and internally it's abstracted out that, hey, we will route your request to the right Ray cluster and a right endpoint, and that's how all the models is going to be. The second step we took was model deployment service, with the goal that the goal was similar in building a tooling itself. Like, we want to reduce the touch points on like what steps to take to make anything happen, and that's how you achieve velocity. So we built tooling that, hey, with one command you can achieve most of the things you want for isolating your compute and resources you need for your use case. We built a one-click deployment service for our users. It's a lightweight deployment service that is deployed in each Ray cluster. And it does a couple of things. So it does. So we have a model registry where once the models are trained, they are checked in, and it will pull model registry. And users can go to model registry and say, hey, I want to deploy this model, and you can define that I want this model deployed in dev, staging, or prod. And we have internally defined the models deployment service in a way that before a user comments says that I want this model on prod, we make sure that the reliability checks have passed. The model has been deployed on staging and is doing well, and only then we go to prod. But in dev, you have way less friction, where like you can just deploy your model, test your models very easily. So it pulls, the deployment service pulls model registry, runs reliability checks, deploys model on Ray clusters. But now we are not using the Kubernetes Helm templates. We are using Ray serve APIs. That allows us to like dynamically launch a model as services on Ray clusters. And the service also emits metrics that is important to not just us, but also to give observability to our users. So once you click, you want your model deployed, you will have all the necessary metrics and observability dashboard where you can go track what is happening. At higher level, this is how the system looks like. If you start from my right to left, like let's say you train a model in our training platform, then the model gets registered. You also store model artifacts on S3 with model weights and model config. So model config is pretty important. It works very closely with the model deployment service that we have. I'll talk more about what goes inside it. But the model deployment service will keep looking at model registry, and it will launch model based on the inference backend that is defined in the model config. If you see, there's a zserv client library that also helps us in abstracting a lot of client parameters that we expect our users to pass. But like, if you are not even then we'll figure out like how to like make your life easy. And if you just need to know what model and the zserv endpoint that you need to call, and we will make sure that the inference happens. So yeah, what does the model config contain? So it contains almost every important detail that we want to achieve what model deployment service does. Like, we want to run reliability checks. You will have reliability check options where you can declare that, hey, these are my inputs and outputs, and go run a check. If not, we have automated some reliability checks for them that runs by default. You can define what your auto scaling config is for, let's say, dev, staging, and prod, very different minimum and maximum replicas that goes there. What is a model type? Like, we support DL models using PyTorch. We use for LLMs, we have VLLM inference backend. What is a parent use case? So your model will only get deployed on the Ray cluster that is dedicated for that use case. We request users to declare what your in and out tensors are, and if your model requires CPU and GPU, and how many, what's the resources that you need for your model. Again, so these are the APIs that we use today. So once we get once the polling from the model registry happens, we use serve.run to start. Basically, we look at the model config, define what the inference engines are. We define this is the inference engine that is implemented already, and we use serve.run to start a model as a service. We use serve.status, and we keep emitting the metrics of serve.status. So once, let's say, user declare that I want this model deployed, serve.status will keep updating model registry and also the metrics on Grafana, where users can go and check what is the status of the model deployment once I have clicked on it. We also do serve.delete to remove models, and this is pretty quickly we can get rid of the model from our serving platform. These are some of the key metrics that we expose to our users so that they can track what is happening. What is the app model status? Is it running? Is it deploying? Is it unhealthy? If it is unhealthy, they can go to look at the logs. If the deploy failed, they can go check what's happening. Pending. Sometimes you can reach a stage where there are just not enough resources to onboard new models, and then you can reach out to us. What is the status of the reliability check? What are the resource utilization? Worker pods count. So whenever we onboard a new use case on our, and we isolate that use case in a Ray cluster, based on the onboarding requirements, we come up with like a Ray cluster where we declare that, okay, this is, if you are in the next 3 to 6 months, if these are the number of models you are planning to deploy, this is the worker count, minimum and maximum replicas that we'll start with. But if you reach a certain level, then you can reach back to us and we can scale it for you. Model performance is tracked in separate set of metrics, and important thing to notice is we track server side and client side metrics for complete picture. So the zserv client library that we just talked about here also emit metrics. So when we are looking at performance, sometimes what we have noticed is your server side metrics can give you a false not a complete picture, and the client side metrics basically helps. What is my client actually looking like when they call my zserv endpoints? And the third thing that we did is we introduced dev environment, which is basically like a very open environment with very limited set of resources for your use case that we start with, where you can, from the model registry, you can deploy something very quickly. If it fails, you can iterate very quickly. Staging environment is where we run our scale tests and reliability checks before promotion to production. And prod environments is where we the deployment service will make sure only the models that are vetted in staging are getting deployed, and we serve the request with high reliability. So that is it. Then we recently started looking into the new features of Ray, and they came up with the Ray Serve LLM APIs and Ray Data LLM APIs. So it's like, hey, why not like make it very easy for our users to deploy a open source, let's say, model or like a fine-tuned model that they have internally in the dev environment. And we had our own custom VLLM backend. We started like, okay, let's experiment with Ray Serve LLM APIs, and they work really quickly. So we introduced Ray Serve LLM APIs into our deployment service, and that enabled our users to quickly iterate on the new models that keep coming up for experimentations. But what we realize is it's not very straightforward to just extend what we do for traditional ML models to the LLMs or the multimodal models, because there is a learning curve in understanding what are the knobs that you need to tune for your workload when you go to production, especially when you're using inference engines like VLLM. And that is where what we if you tune it for one use case and then you just copy paste it for others, it generally does not give you the best performance. So we are still trying to figure out like how do we introduce those reliability checks in place for these workloads, and that is still work in progress. So we allow users to deploy the models in dev, but for production that is still work in progress, where we still like help them out a bit before they go to production. We also experimented with Ray Data LLM. We have a lot of eval jobs internally, and we set up a persistent Ray cluster with our like custom code in a Docker image, and we started using Ray Data LLM to like reduce the complexity of the code of the job that we run, and it really helped. We were able to reduce the amount of code we write for those jobs, and also get improvements on the runtime by 60%. And we have a talk by one of my teammate Anindya today in the evening, where he will we'll go more into like how to use Ray Data LLM for like image or video use cases. The key result. So from velocity point of view, we reduced the deployment time from sometimes days to minutes. We came up with isolated dev environments for quick iterations for our users. We run batch inference jobs on multimodal data and LLMs, and that are running faster by 60% for our users. For reliability, we basically automated reliability checks in a deployment service, so it allows you to test your models very quickly. And we isolated our use cases in different Ray clusters, and compute allows us to test them and establish expectations very clearly. And also observability on both client side and server side is one of the key things that we do to make sure that our users are having a good time when they're using our platform to get the complete picture. Thank you. This was my presentation, and as a customary thing, we are hiring, and if you are interested in the work that we are doing, go to zoox.com/careers, and I'm sure you'll find something interesting, and if you're interested, reach out. Thank you. Question? Yeah.
Can I just ask?
Yeah, sure.
So if you add the peak RPS of all your models at the peak, how much is it?
The peak QPS, I think we have, as I said, like the use cases are very different for us. Some of them, are heavy batch requests, and the RPS that we generally look at peak when we are like using some busty QPS use cases that are coming in, we reach at like 100 to 200 QPS.
Like the total platform?
No, that is like the top use case that sends 100 to 200 QPS. Collectively, I'm sort of missing on a number. What exactly is the QPS for every day? Yeah.
So the last question is, what happens with the features?
Sorry?
Who sends the features for the models
Yes.
where they are coming from?
Yeah, so features currently, if you see the model config, right, where we define what the features are, inputs and outputs. So today we have a system where the features that we like our users want to use, they are still, we don't have a complete feature store story yet, where like all the features are in one place and you query the feature store and you send the features. So right now it is the responsibility of our client to send the tensors that they want to use for inference, and they make sure that happens and they send it to us. But yeah, now as we grow, we are gonna have like the product software use cases where we'll need to have a feature store story where like, hey, this is the one place where you define your features, will get populated with like certain cadence, and that's what we'll use for the product software use cases. Yeah. Yeah.
Do you do rolling updates, like when you deploy a new version of the same model, or do you do looping?
So in our platform, each model is sort of like idempotent to like, they are like, if you do any update to the existing model, it will generate a new version. So each model has its unique version ID. And the way we do it is whenever a user wants to like deploy that model, it has to go through the whole life cycle of like, hey, test and staging before it goes to promote. And the deployment service will basically be like, hey, this is the new version, and user has marked it as like, I want to test it or like, promote it, and then it will go through the whole cycle. But yeah, if you update anything in the let's say you update the model weights for that particular version, it will not get picked up until the restart of the service happens or like something else takes in.
It makes sense. So
Yeah.
the current version is running in production.
Yes.
I want to deploy the new version.
Yeah.
So would you like create like new resources for the new model and then shut down the resources?
Yes, exactly. That's what we do.
So it's blue green.
Yeah.
So are you deploying multiple models on the same GPU, like are they sharing the GPU?
Yeah, so we do if you see in the model config, we define CPUs and GPUs, and then we also define how much GPU we want to use. For like larger models, we tend to not like share GPUs with others, but like if it's smaller models, we do take advantage of like let's say 0.5 GPU for this particular model.
And then have you seen like regression in terms of like these models interfering with each other in terms of work?
Yeah, so far no. Actually, that was one thing that we were very careful before we like allowed users to declare, let's say 0.25, 0.5 GPUs. We ran our own tests to see that, hey, does it like create any problems when like, is there any spilling going on or like does it into regression? But we didn't find any conclusive evidence that this is happening at many scale. Yeah.
So have you evaluated Triton influence server multimodal endpoint with your use case? Because sounds like it's a good fit because you just need to pack in the new model and upload it to the S3 bucket, and then the model is automatically deployed, and you can serve so many models behind one endpoint, and if not all of them are always highly dense.
Yeah, so good question. So for the Triton inference, as a matter of fact, we are actually diving more deeper into that as well. But for like a slightly different use cases where what we realize is when we are running like heavy simulation workloads, even the network cost is very high. So like, if you're sending like heavy tensors, what we realize is like whatever the latency gains that we wanted to gain, like we were not seeing it because the network was just adding so much. So we're like, hey, can I bring up ML model server closer to where like, my client is already? So as like a small container that we can just pass on. So that's where like we are exploring Triton inference servers more closely to our clients. But again, we don't have like solid results yet. But if that becomes like something that our users are very, and it serves the purpose of like saving the latency or the network bandwidth and all of that stuff, then we'll explore more on like, hey, can we do this like for other models as well? So it's like work in progress. Maybe like if we have reached that point, we'll present it what the results are. Yeah.
Question, you mentioned one model per RAID cluster. Are you leveraging the routing?
Yeah, so it's not one model per ray cluster. It's like one ray cluster for each use case. And use case can have multiple models. But how we define use case is based on what is the expected request pattern and all of that stuff. So like I don't want two very different kind of models serving very different purposes on the same ray cluster. That's the idea.
And then you are leveraging the RAID,
Yeah.
like reserve routing.
Yeah, exactly. Yeah. Cool. Thank you. And sorry.
Can you just talk a bit more about the staging environment and the scale tests? Like, when do those tests involve? And like, what are you testing for in that staging environment?
Yeah, so for staging environment, like once, let's say you have tested your model in dev, and dev will give you like confidence that, hey, this model can be, at least it is compatible with the model serving platform that we have built. It gives me the response that I expect once the model is on staging. So we have built tooling where you can trigger a scale test for your expected QPS to see all these auto scaling config that you have configured, the replicas you have configured are good enough for the QPS that you expect. And again, we have built a lot of tooling to make sure that our users can do what they want at one click. So that's basically what we're trying to achieve. Yeah.
Do you guys also do like shadow deployments?
Shadow deployments, we haven't had. Again, that is something I want to explore with product software use cases that we onboard in next phase of our platform. where like, shadow testing where can be like, hey, this is my model, but I want to shadow for the same request, do shadow predictions on this model so that I can start collecting data for it and see like if it's doing a good job or not. We have not reached there yet for like, or like we have not done it for the use case that we have today because they tend to not have such use cases. But once you go in the product software side, I'm sure these becomes like key important features for our platform.
Sorry, one last question. What is the biggest Ray clusters you have in the serving? How many?
Worker parts? Yeah, actually, like before we divided, we reached like 200 worker parts. Yeah, and then we realized that we are hitting some of these reliability issues that I just mentioned, and then we sort of like isolated, and now we have
How many Ray clusters?
yeah. So currently,
Single cluster, what's the max number of Ray clusters you have?
so Ray clusters are okay. I think I've been told that the time is up, but I can chat more like beyond this. Thank you so much. Yeah.